quantum entanglement. So this is very exciting topics nowadays in physics community. I will explain to you what it is and what the issue is, so you can enjoy some of YouTube video. Usually photon, when it's generated, the photon generator is like LED light source. The so-called parameters spin can be up or down, and if you measure, it's like probability function. Or polarization, it could be vertical or horizontal. So we know that the quantum particles behave like a probability. So when this entanglement story started, well, some special crystal, you go through photon, it's split into two photon, 1 and 2, and they seem to be entangled. What do you mean by entangled? It means when you measure one, it could be spin up, the other one you measure always down. Or when you measure polarization, it's vertical, the other one is horizontal. Okay, the result is guaranteed. That means it's 100% correlated, negatively correlated, because one is up, other is down, one is horizontal, one is vertical. So negative correlated, but 100% correlated. So it's like you have a two spinning coin, you stop one, it's a head, other one is guaranteed to be tail. How can it be? They must be communicating somehow. Okay, so this is very magical phenomena in quantum mechanics. Now, even more problem is the scientists tested how fast they communicate. They did a clever experiment. Say they measure this side and this side far apart and at the same time, so that there's no way they can communicate at the light speed. Okay, premise is any communication should be equal or slower than the light speed. So they did it at the same time. There's no way they can communicate, but still guaranteed. So scientists made a big mistake here. Okay, communication is faster than light speed. They assume it's instantaneous. Then Einstein got mad. He said, spooky action at the distance. Why? Because if something, two events happen at the distance away at the same time for the cause of one thing, it's a problem. It's a locality issue. It's going to break every physical law. So Einstein rigorously against the idea that they're communicating instantaneously. Well, that was a wrong assumption scientists made. It was faster than light speed, so they automatically thought it's instantaneous communication. So Einstein proposed, maybe when photon is generated here, it's already decided whether it's red or black. And entangled pair is like you get red, black or red. So it's guaranteed you get the other one. Okay, so preset mechanism, Einstein said there may be a preset mechanism that the photon behave that way. Okay, but this is against the other experiment, which I'm going to explain. Okay, so what happened is Einstein's idea is probability decided here. Okay, but quantum mechanics experiment said probability happened when you measure. Until then it's spinning, so you don't know which one you get it. Until you measure, you don't know the result. But Einstein's proposed maybe it's decided here. It's just you have a black card and red card, or red card or black card. Okay, now this is against the quantum mechanics various experiment. The simple one is quantum polarization. Okay, when you generate the photon, and if you have vertically polarized filter, so only vertically polarized photon go through. Then you give another filter which is horizontally polarized, then no more photon come out, so 0 here. Okay, but quantum mechanics works this way. You go through vertically polarized filter, it's all the vertical, then you give 45-degree polarized filter. So what's happened is vertical has some probability to produce 45-degree. It's a probability function. So some photon goes through. Then you give horizontal, then it's again 45, so some photon go through. So strangely enough, the photon go through this 3 set of filter, but this set of filter it cannot go through. So what does this mean? The photon is deciding which way to go by probability function every time. Okay, now Einstein argued, well, there may be some internal mechanism to behave this way. So Bell, he did extensive experiment. That's not the case. Okay, so this is a big problem. Now somewhat we got more understanding. It's not instantaneous speed, they are communicating. The two entangled photon, they are communicating somehow, even far away. How far? Well, Chinese experiment, they did like satellite and Earth distance, still communicate. And this communication speed is faster than light speed. So this is something beyond Einstein's theory. Okay, so that's bring the excitement to the quantum mechanics right now. Everybody talking about entanglement. Well, such a strange phenomena, what is it good about? What we can do with entanglement is called quantum encryption. Every data in the internet is encrypted by a key. And right now we have a secret key to use, so nobody can unlock it to see the data, right? But somehow the key is copied somewhere, then everything is broken. Okay, when you use entanglement pair, the photon 1, photon 2, it's guaranteed to be complementary digital pattern. So you generate the entanglement pair and measure one of them. Sender keep this and send another photon to receiver. Okay, then receiver has exactly same key as the sender, and nobody can steal the copy, because somebody steal the copy here, then receiver never get the full set, so he never send the data. Request to sender to send key again. So the owner of the key will be only sender, and the receiver is guaranteed. And no matter how far they are, doesn't matter, it still communicate. So this is a new way of doing communication with secured encryption. Okay, this is big. because internet, the weakness is encryption key. They have to guard encryption key very tightly. Otherwise, somebody steal the copy, then everybody can be encrypted and the data is read by whoever stole it. But quantum encryption guarantee, it's never happened because only sender and the receiver will have a key. Another possible application is quantum radar. So what happens is you shoot one photon to the object, and when it's hit, and the entanglement break is called the coherence. Okay, and you measure the time. Measure the time to break the entanglement. You can measure the distance. Okay, so whatever the object over large area, this floating object can be detected. Okay, there are more applications proposed by quantum entanglement. So we don't know how they communicate, but a pair of quantum photons are communicating, and that is a very valuable result of science. We will see many new products coming out using that result. Okay, we have other physics videos. If you're interested, please check it out. Thank you.